Okay, welcome everybody to our second session on Tuesday, October 5th. We're pleased to have Jim Bodkin sharing with us his experience, knowledge, and understanding of lessons from other translocations of sea otters. Jim is, as you can see from the glamour shot here on the boat, Jim has spent a lot of time in the water with these animals and understands the ins and outs of translocations, their success, failure, that kind of thing. So without further ado, I'm going to unshare screen and Jim will take it from here and we'll go until 2:30. Thanks, Jim, so much for participating in this. This has been really great. This is Jim's second rodeo with presenting to one of our symposia. So thanks again, Jim.
Thank you, Bob.
Now you can share your screen and we're good to go.
I assume that means that is not being shared.
Not yet.
Okay. Then I need some help. I'm going to go back here. All right, here it is.
No little green button at the bottom.
There is. I think it's coming up now.
Looks good. All right. I'm on mute.
Okay. I'm having some difficulty with the other screen that I'm not seeing.
We are seeing your screen, Jim, the one lessons learned.
Right. There's another screen that I need to see.
Oh, it's your notes, I see.
You do see that?
No, we don't.
Oh, right.
You know what's helpful is if you stop your screen share and then present with notes view and then share your screen, I believe your notes will be available to see then.
Okay, I think that are you still seeing my screen?
Yes.
Okay, great. I can continue now. Their only issue is that that's fine. Okay. All right, Bob. Well, thanks for the introduction and thanks to the Elakha Alliance for inviting me to speak about the history of sea otter translocations. And also thanks to the Elakha Alliance for their work towards restoring the nearshore ecosystems in Oregon through the introduction of sea otters. So a brief introduction outline from me. I'm going to talk, as Tim said, about the history of sea otter translocations. There's been quite a few of them, and you're going to become familiar with nearly all of them. I'm going to go into a little additional depth into the first Oregon translocation, and I'm going to try to summarize the range of lessons that have been learned and how those have been applied through the course of the history of the translocations. And then I'm going to talk finally about some options that those who are involved with designing of a potential Oregon translocation might consider. So the first sea otter translocation took place in 1937 when 9 animals were captured on Medney Island, a part of the Commander Islands in the Western North Pacific. And this began a 9,000 kilometer odyssey from Medney Island to the Barents Sea near the Russian-Norway border. Now, the goal of this translocation was actually to establish a sea otter population outside of their historic range near the Barents Sea. And this is described in depth in the 1947 monograph by Barabash Nikiforov, which I would encourage you, if you have an interest in early sea otter literature, and the translocation that I'll describe briefly. There's a thorough description in that monograph. So this first leg was a 3,000 kilometer journey from the Commander Islands to Vladivostok by ship. Now, unfortunately, 7 of the 9 animals that were transported had died before they reached Vladivostok. But 2 animals survived. Unfortunately for them, they were both males, unfortunately for the population that was being planned, they were both males. And they were then shipped by transcontinental train to the Merman shore and housed in an intertidal enclosure that was built specifically to accommodate those 9 animals. They persisted in this enclosure until one animal escaped in 1940 and apparently survived for some time in the wild. But in 1942, the remaining animal in captivity was euthanized as a result of the beginning of World War II. So that was the very first translocation, a rather ambitious undertaking. The next 5 translocations took place in Alaska, and these were from 1951 to 1959. And these were the first efforts that were directed at reestablishing sea otters in former habitat through translocation. And during this time period, 86 sea otters, they were all captured from San Nicolas Island. There were 4 efforts to move animals to the Pribilof Islands, 81 animals in total. And then there was 1 movement of animals, 5 animals from Amchitka to Attu Island. And this work demonstrated the need for recognition of the sea otter biology and the basic husbandry practices, because nearly 70% of the animals, of those 86 animals that were targeted for translocation, died. Many of them in captivity prior to transport, and many of them during the transport. And very few of them were actually alive for the final releases. And so mortality, pre-release mortality, was a significant factor in the failure of these early efforts. So you're going to see some diagrams similar to this one with an arrow going from either Amchitka Island to various reintroduction locations, or from Prince William Sound to other recipient populations. So, but these efforts from Amchitka to the Pribilofs and the Attu were both failures completely, but they did lead to the lessons learned that would provide for the successful future translocations and recovery of sea otters. So I'm going to pose the question, why did these early attempts to hold, transport, and sea otters fail? Well, the simple answer is that biology is critical in these types of endeavors. There was a failure to recognize the critical role that the sea otter pelage plays in achieving and maintaining thermal neutrality that is essential to their life. Because they lacked access to clean and adequate water and space, they were essentially unable to survive. They were exposed frequently to long transport times. You can imagine a transcontinental journey across the continent of Asia, and often in harsh environmental conditions. They were also given inadequate quantities of food, on the order of 10% of their body mass, whereas today 20 or 25% might be recommended. And they were also given kind of inappropriate types of food, or foods that they're not typically consuming, things like seal and waterfowl. So these are some of the factors that led to the failure of these initial attempts. So now we're going to talk about the first of the successful sea otter translocations that began in 1965 through 1972. And these were cooperative programs between various state and federal agencies to aid in the recovery and the establishment of new colonies, including for possible eventual fur harvests. So during this period, 708 sea otters were translocated to 12 sites, including the Pribilof Islands, Southeast Alaska, British Columbia, Washington, and Oregon. So I'm going to show you some photographs of the source populations, and I'll eventually show you some photographs of the recipient populations, the habitats, just to give you a sense of the variation in the types of habitats that sea otters can occupy. So this is a picture of the Pacific coast of Amchitka Island, and this is where most of those animals that were translocated originated from. And it was also the site of the 1971 Canakin nuclear test. Now, I'm not proposing that there was any relationship between these two activities, but I suspect that at least there was some logistic support that was gained by having these events going on simultaneously. But you can see here, this is a kind of a rugged open ocean coast, large oceanic swells with some protected areas in there as well. So the other source population for these translocation was Prince William Sound. This is a very large estuary in the northern Gulf of Alaska. It's also the site of the Exxon Valdez oil spill. And generally, these are more protected waters with some open exposure at the entrances into Prince William Sound. So there's 13 separate translocations from Amchitka and Prince William Sound to Southeast Alaska. 39 animals were shipped to 6 different locations over the course of 5 years. There was also 55 animals moved from Amchitka to the Pribilof Islands in a single event over 1 year. And although these animals persisted for about a decade, they eventually vanished from the Pribilofs. Although sea otters are occasionally seen in the Pribilofs today, probably as a result of immigration to that area. And I want to show you where the Pribilofs is. If I can get my laser point, this is the Pribilof areas up here, Amchitka Island here, and Prince William Sound here. Southeast Alaska, British Columbia, Washington, and Oregon. The next one, translocation was to British Columbia. 89 animals moved over 4 years. And then finally, animals from Amchitka went to Washington. 59 individuals over the course of 3 years. And then, of course, the one that you're probably most familiar with, the Oregon translocation, 93 animals over 2 years. And as we know, this one eventually vanished as well. But today, there's perhaps 50 or 60,000 animals that resulted from these 700 animals that were translocated. Now, we could view this as some failures and some successes, but if we view this as an attempt to recolonize, reestablish sea otters throughout much of their range, I think all of these translocations could be viewed as a partial success or contributing to what is now a fairly large number of animals. That's probably approaching 40 or 50% of the global population, as Tim spoke about earlier. So no matter how you look at it, these translocations have been hugely successful. And here's a photograph that was taken a few weeks ago in Southeast Alaska. It's a group of several hundreds of animals. I've tried to count it numerous times, and I can't get past about 150 without losing my way. But this is a group that was photographed in icy straits at the mouth of Glacier Bay, just to give you a sense of what these translocations can result in. So there's more recent translocations to consider. And I call these the modern translocations because I guess these are the ones that I could participate in. But from 1987 to 1990, 139 sea otters were moved from the central California coast to San Nicolas Island in Southern California, one of the California islands. Now, by this time, the husbandry practices had been greatly improved, and all animals handled were under stringent protocols and permits, and their survival was almost 100%. There were a few a few cases where there was some incidental mortalities, but in general, mortalities associated with the capture and transportation have been reduced to near zero. Now, all animals were tagged. Many received radio implants, some as much as a year before the translocation. Many of the animals were monitored prior to arriving at San Nicolas Island, and most were held at the Monterey Bay Aquarium, and all were monitored after release. A decade was spent in pre-treatment ecosystem monitoring that continues today, as well as the population level surveys. However, despite the improvements in the husbandry and in the transportation aspects of translocation, in 1993, only a dozen animals remained. So here's a photograph of part of San Nicolas Island, and this is very near the site where translocated otters were released. And the point I wanted to make here was that sea otters never remain at the sites where we release them. They disperse quickly. In this case, they moved about as far as they possibly could. Those animals that became established were about as far as they possibly could be from this release site and still be at San Nicolas Island. And we've seen this in other translocations where animals, they just don't want to be where they are released. But because animals were instrumented with radio transmitters, and because we had a fairly intensive effort to monitor post-release abundances and distribution of sea otters, we have some fairly interesting results. So these include, and I have you can see the location of San Nicolas Island here. This is the Los Angeles Basin here, Point Conception here, and San Diego down here, and San Nicolas Island here. 58% of the adults that were shipped out to San Nicolas Island returned to the mainland, and most of those back to or near their home ranges in the Big Sur coastline. And only 15% of the subadults returned. On average, adults left San Nicolas Island within 41 days, and the subadults within 81 days. Adults returned to within a few kilometers of their prior home ranges on the Big Sur coast, where the subadults generally did not return to their home ranges, at least within an average of 100 kilometers, which is far beyond what the average home range is. So these results suggest that subadult animals were less likely to disperse or return to their capture sites, and supports the strategy of focusing on moving young female animals. So we're going to look at, there's a plot of the San Nicolas Island population from the time of release, a rapid diminishment, and then there's a prolonged period here, a decade or more, where the animals basically stayed at the abundance of somewhere in the mid-teens, some slight changes. This is a period 5 years after the last translocation, and the population reached its low point. And it's, I would suggest that at this point, this population could have continued as it did, or this is the trajectory it took, but it easily could have gone down in this direction as well. We were sitting at the edge of our chairs for a number of years here to see what would happen. But eventually, after about 10 years, significant growth began. And today there's probably close to 125 or more sea otters here. And this growth rate the last 5 years exceeds 10% per year. I also need to add that incidental mortality related to fisheries is likely a contributing factor to the delayed growth in this prolonged period at a relatively low population size. So keep in mind where this is, 5 years, and you're going to see another plot in a few minutes. That star is going to be there as well. Okay, the next translocation, I'm going to call it a novel translocation because it differs substantially from the translocations that you've heard about previously. And this is reported by Carl Mayer and his authors in a paper in 2019. When 37 stranded sea otter pups were raised by surrogate females in captivity at the Monterey Bay Aquarium and eventually moved to nearby Elkhorn Slough. Okay, so here's a photograph. You saw an overhead, I think, image of Elkhorn Slough. Here's one from ground level, just to give you an idea of the kind of the range of habitats that sea otters occupy. With the exception of parts of Puget Sound and the Salish Sea, there's not evident that there is any habitats throughout the North Pacific, the historic range of sea otters, that they did not occupy. And that would include these estuaries. So Elkhorn Slough results. They had a very high retention rates, and they calculated these a little bit differently. An animal had to be seen for 2 weeks and remain in the slough for 2 weeks before they started calculating these rates. So they calculated them a little bit differently because they had the option of recapturing animals that they thought needed to go back into captivity, return them to captivity, and then re-release them. So, but they did have very high retention rates. They had survival and reproductive rates of these animals, of these surrogate raised pups that were not different than the wild animals on the coast that were also being monitored. And this effort did contribute to population growth in the region of the central Monterey Bay. Now, this project was unique in several aspects. It was a 15-year effort, okay? It's a fairly substantial long-term effort to raise and introduce these pups. They engaged captive adult females to rear these pups. These pups were held in captivity for 6 months to a year and a half. Implanted pups were released, 1 to a few animals at a time, and they were intensively monitored multiple times a day, 7 days a week, and they were often recaptured for additional treatment in captivity. And contrary to the other translocations, they were introduced into a sheltered, occupied nearby estuary habitat. Now, the upper estuary was probably not fully occupied based on the number of animals that eventually occurred there, but Elkhorn Slough was occupied by sea otters for several decades, although not necessarily in the upper reaches where these young animals tended to aggregate. Okay, now we're going to get to the Oregon sea otter translocation, 1970 and 1971, when 93 sea otters from Amchitka Island were brought in two years. The first year in 1970, 29 animals were released near Port Orford. And this photograph below, I think, is a photograph of the plane that actually brought the animals to somewhere near Port Orford. Thanks to Bob for providing that to me. In 1971, an additional 24 animals were released near Port Orford and 40 at Simpson Reef north of Port Orford. And this was really the first of these translocations that had a very intensive follow-up. All of the other translocations were followed up as animals became conspicuous and abundant. There were very few attempts to quantify kind of the success or failure of those translocations, and only when they became obvious was much effort put into monitoring them. But in this case, Ron Jameson did his master's thesis on the Oregon coast following these animals from essentially shortly after the translocation through 1974, and he continued, I think, until the last sea otter was observed in Oregon. So a summary of the Oregon translocation. It was about 60 females and about 30 males, a 2-to-1 ratio, which is what was prescribed. The difference with this translocation was that despite the recommendation of having predominantly young females, this was predominantly adult females. 70% of the females were adults and 30% were subadults. And it was just the converse for the males, where 70% of those were subadult and 30% were adults. And I have to go back and say that it was generally thought that younger animals would be less likely to disperse or emigrate back to their home ranges because they had not yet established those. So rapid dispersal was observed in the surveys that were conducted shortly after the translocation. And there's a range of estimates of the retention post 1971. It could go from 20 to 35%, depending on kind of the underlying assumptions that are made, but not a bad retention rate compared to Washington, which was probably down around 10% or 10 animals. So it had a very low founding population size. There were 8 carcasses recovered in the first weeks after those 2 reintroductions. And I think it was by 1974, a total of 14 animals carcasses had been recovered, and 1 likely shark attack source of mortality. And Simpson Reef and Blanco Reefs were the areas of concentration where animals appeared to establish themselves. And here's an interesting kind of finding. The first pup was located in 1972. That doesn't mean that pups weren't born before then, but this was the first one that was observed. But what I find really interesting is through 1974 that there were 17 pups produced. And of course, that means that there was at least 17 females, because they only have a single pup per female, which would have been a kind of a minimum population size of 35 if you assume that there had to have been at least 1 female. I'm sorry, 1 male to produce those pups. But clearly there was a larger population than that. But clearly it was these pups did not survive, and I'll show you in the next graph. Basically, the abundance of sea otters in Oregon post the introductions. So this starts in 1972. And these are actual counts that, as you can see, by 1976, 5 years after that, the population had achieved a number that was similar to, maybe a few animals less than that at San Nicolas Island. But rather than staying at a low abundance for many more years, it continued on its decline, with the last animal being observed in 1981. So now I'd like to ask some of the question of why were some of these translocations more successful than others? Now, in general, success was positively correlated with the number of animals that were introduced. The larger number of animals that were introduced, the larger the sooner and the larger the populations became evident. The number of reintroductions that occurred, again, the success was positively correlated with those number of reintroductions. It was positively correlated with the amount of the suitable habitat available, or what might be viewed as the eventual carrying capacity of that habitat. And there was some correlations with the complexity of the habitat, with Southeast Alaska being the most complex habitat, and the Washington and Oregon coastlines having perhaps the less complex. And it seemed like that it was pretty clear that reproduction was not an issue in any of the translocations, San Nicolas Island and Oregon. There was a great deal of reproduction, but there was no population growth. So essentially, it's the survival, either in terms of the mortality of those pups or their departure or emigration from the island. And so this begs the question of why were some of these translocations less successful than others? Another way to look at this. In this case, instead of biology being critical, I'm going to say that behavior is critical. Now, in all cases, numbers decline rapidly. And because there's a high fidelity to a small home range. And this is because of the social structure and the relations amongst individuals, maternal, paternal, sibling, and other types of associations in animals that have acquired and remained in a home range for any period of time. And this is likely a result of internal mechanisms that are designed to maintain population size at a point at or near equilibrium with food resources. There's a general aversion to release sites. And the age and sex structure of the founding or the translocated animals and relations with pup survival questions appear to be important. And again, in these very small populations, stochastic events can play a very important role in determining where those populations eventually end up. Now, I'm going to ask, I see I'm at 30 minutes and I still have a few more slides. Would you like me to wrap this up quickly? I'm going to ask Bob or Chanel.
Yeah, that'd be great, just so we can stay on schedule for Michelle and Mike.
Okay.
Thanks.
Okay. Reintroductions have been hugely successful as a conservation tool. A large fraction of today's populations are a result. There's benefits from multiple sources, benefits from multiple years. Emigration is a commonality, and uncertainty is a concern. But despite that uncertainty, clearly, history supports that given the will, that you can be successful in helping to restore Oregon's nearshore ecosystem through reintroducing sea otters. And I will wrap it up with that. Thanks for your attention.